This video is about dividing by fractions. You may have heard that dividing by a fraction is the same as multiplying by its reciprocal, which is true, but we want to understand why that's the case. So let's start with division in general and be able to visualize it and then see why it works when dividing by a fraction to multiply by its reciprocal. So let's first consider the problem 4 divided by 2. And once again, let's visualize that. So 4, let's actually block out 4 blocks. So we have 4 units. What does it mean to divide by 2? Remember that division is repeated subtraction. We want to see how many times we can subtract 2 units away from 4. So let's go ahead and divide this up into 2 unit sizes. So here's one block of 2 units. We could subtract one of them. And then we could turn around and subtract another one of size 2 units. And turns out we can do it exactly twice. So we could subtract 2 twice exactly. If you understand that division is repeated subtraction, then it will make a little bit more sense when we talk about, instead of dividing 4 in half, we want to talk about dividing 4 into halves. It's very different than dividing 4 in half. So that would be what 4 divided by 1/2 is. Now it's more conventional by mathematicians to drop the division sign and write this as a fraction. So 4, a fraction with a fraction in the denominator. Okay, so once again we need to start with 4 blocks. But this time, notice the denominator is 1/2. So what do we need to do? We need to subtract 1/2 repeatedly. Now let's figure out, okay, so there's 1/2. We could subtract that. Another 1/2. Subtract that. Keep on going. We're up to 4 subtractions already. If we keep on going, that's 5 subtractions. 6 subtractions of half units. 7, and finally 8. In other words, we could subtract 1/2 8 times. So 1/2 can be subtracted from 4 8 times, and notice that is exactly twice 4. Why does that work? Because we've taken each 1 unit and it takes 2 half units to fill each 1 unit. Therefore, 4 times 2 over 1, which is the reciprocal of 1 over 2, is equal to 8. So multiplying by the reciprocal worked nicely. Now let's consider another one that's just a little bit more complicated. Let me clear the page here. Let's take 4 and divide it by 1/3. Okay, which could also be written as 4 divided by the fraction 1/3. So let's bear in mind we're repeatedly subtracting 1/3. We want to figure out how many units of size 1/3 could fit into 4 units. So we have to take each and every unit. There's a third of a unit. There's another third of a unit, and another third of a unit. And notice there were 3 subdivisions, let's call them, per unit. So it would take 3 steps of size 1/3 to get to 1. Now, if we're going to continue doing that to get all the way to 4, we would end up needing 12 of them. So the answer, if I continue to slice it up, you can count them up. If you want to pause the video, you'll have plenty of time to count it. But we could repeatedly subtract 1/3 from 4 12 times. So we could repeatedly subtract 1/3 12 times in this particular case. So once again, this seems to reaffirm that we could take the number of units, and instead of dividing by 1/3, we could multiply by its reciprocal, which would be 3/1, and we get 12/1, or just 12. Let's consider another example. Let's take 4 divided by 2/3. Okay, so we could rewrite that as 4/2/3. And let's draw out 4 units. 1, 2, 3, 4. Now 2/3 of a block, that's twice as big as what we had before, so we probably can only fit half as many. So there's 2/3. There's another 2/3, and now we have one more 2/3 in there. And now we have to go up another 2/3, another 2/3, and finally one more. So we have 1, 2, 3, 4, 5, 6. So we can subtract 2/3 repeatedly subtract 2/3. Six times, which is exactly half of what we had before. Well, lo and behold, if we take 4 and divide it, let me just cross that out. So if we take 4 and multiply by 3/2, consider 4 as 4/1. So if we multiply by 3/2 instead of dividing by 2/3, we can take what's in the numerator and get 12 and divide that by 2, and we get 6. So we can do half as many subtractions when we're trying to fit in, when we're subtracting out 2/3 at a time instead of 1/3 at a time. Let's finally work with a fraction divided by a fraction. So far, every example has been an integer, specifically the integer 4 divided by a fraction. Let's take 5/2 and divide it into by 3/2. So this could be rewritten as 5/2 over 3/2, or sometimes in the math textbook you'll see it's getting a little bit small here. Let me just scribble that out. Go back. You would see 5/2 and then a larger bar over 3/2, indicating there's sort of implied parentheses here. We have the fraction 5/2 in the numerator of a numerator, and the fraction 3/2 in the denominator of the larger fraction, the outermost fraction, I should say. So we know mechanically we should be able to simply take 5/2, instead of dividing by 3/2, we could multiply by 2/3, and we should get 5/3, which is 1 2/3. Well, let's work this out visually. So let's bear in mind 5 divided by 3/2 is really saying how many times can we subtract 3/2 from 5. Subtractions of 3/2, I said from 5, I meant to say from 5/2. Okay, so let's see what happens. If I draw 5 units, let's go horizontally this time. 1, 2, 3, 4, 5. Now I need to subtract. I'm sorry, this is absolutely wrong. We want exactly half of this because we want 5/2, not 5. So let me get rid of the other part of this. Okay, so now we need to subtract 3/2 and see what happens. So 3/2, that's the same as 1.5, so I can clearly subtract it once. But the second subtraction would take me out to here. We didn't quite fit that in. How many of the second subtractions fit in? We got 2/3 of the second subtraction in. So 3/2 could be subtracted completely once, but only 2/3 of a second time. So our answer of 1 2/3 makes perfect sense. So multiplying, we can see right here, instead of dividing by 3/2, multiplying by the reciprocal of 3/2, which is 2/3, gives us exactly the right answer.